As we completed on studying Antwerp porthouses construction process, we started to be curious of how different types of energy were supplied to the building that floats above the ground. And as we researched, we have found a very interesting topic, which is Antwerp porthouse achieved very good rating in BREEAM evaluation. BREEAM is one of the global leading green building rating systems that is used to measure the environmental performance of new and existing building. It stands for Building, Research, Establishment, Environmental, Assessment Method. BREEAM assessment uses recognized measures of performance to evaluate the building's specifications, design, construction, and use. These measures are set against 9 categories, including energy, management, health and well-being, materials, transport, water, waste, pollution, and land use and ecology. Each of the criteria is scored and then multiplied by the weighting. The resulting overall score is then translated into a rating on a scale of BREEAM certification levels: pass, good, very good, excellent, and outstanding. As now we know what is BREEAM, let us see why Antwerp porthouse achieved very good rating. In BREEAM assessment, a borehole energy system, chilled beams method, chilled ceiling method, and optimal light control attributed the most to receive very good rating. Then now, we must understand what borehole energy system is. In order to provide efficient local cooling and heating, a borehole energy system pumps water to a depth of 80 meters below grade in over 100 locations around the building to provide heating and cooling. In the wintertime, for heating process, using the principle of heat always flows from a higher temperature to a lower temperature, temperature underground is higher than the surface air, so the cool liquid traveling down from the inside of the building absorbs heat from the underground and brings it back to the building. Then the heat pump compresses the liquid, increasing the liquid's temperature, which warms the air. And the warm air circulates around the building and turns back into cooler air. Then the cooled liquid is pumped back into the ground to continue the cycle, forming a closed loop. In the summertime, this process is reversed. The lower temperature refrigerant absorbs heat from the house, which now has a higher temperature than the underground, and the heated liquid transfers heat from the house into the ground and returns back up into the house cooled off. With the borehole thermal energy system, chilled beam method is used for cooling and heating process in pre-existing building that stands below. A chilled beam is an air distribution device with an integral coil that may be installed within a space in order to provide sensible cooling and heating. When cooling, cooled air from the borehole thermal energy system is circulated into the coil, and when heating, heated air is circulated into the coil. There are 4 massive benefits: efficiency, space saving, better air quality, and lower maintenance cost. A chilled beams relies on the heat transfer of water versus air, meaning you only need to circulate small volumes of water to do the same amount of cooling as air, saving energy along the way. Secondly, as chilled beams still require dehumidified air from the central plant, they require a lot less primary air, meaning lower fan power and smaller ductwork, which leads to space saving. Thirdly, as the total volume of air distributed is fairly small, it can be comprised of 100% outside air. This offers a fresher tenant environment with no more stale air being recirculated through the building. Fourthly, chilled beams have no moving parts of filters, making them virtually maintenance-free and far less expensive over their lifetime. If the pre-existing building used chilled beams for heating and cooling process, the newly added building used chilled ceiling method for heating and cooling method. Chilled ceilings differ from chilled beams. A chilled ceiling is a metal sheet with water pipes running above it. The pipes heat or cool the metal panel, which then radiates that energy toward the building occupants. In cooling process, it absorbs the heat radiation from people, electronic devices, and other surfaces, which drops the temperature. And in heating process, it radiates the heat to the surrounding. Through this device, the interior of Antwerp Porthouse was able to be cooled or heated without any noise. The sound absorbing effect increases comfort level further. Lastly, optimal light control through the new facade also supports on energy efficiency. As we explained in the past video, Groven Plus and Saint Gobain oversaw facade construction, and 3 types of glass panel were attached to each other to create one spandrel glass. Plani-Clear, diamond, and Antalio silver products were attached together to make a one spandrel glass panel, which prevents materials or construction elements from being viewed from the exterior and absorb solar heat and allow high level of light transmission. The lower iron content of Plani-Clear, diamond, and Antalio silver reduces the level of absorption itself, thereby increasing the level of solar gain into the building. Also, lower iron content contributes to a higher level of light transmission. This helps to increase the level of natural daylight into the building and reduces the need for artificial lighting.
And from now on, we will talk about the facility of the Antwerp Porthouse. We found that it also requires a lot of consideration to install facilities like heating, ventilation in such a large building. So let's see how heating, ventilation, and air conditioning system, called HVAC facilities, are installed. Every facility constructors who participated in installing heat source or air handling units said that technically deciding the devices to install was not difficult, because prior to HVAC construction, there was so much consideration for energy saving system we told you at the beginning. The common challenge for internal facility constructor was arrangement and actual installation, because every edge and line of the Antwerp Porthouse was not straight line. They had to make everything into the picture, and sometimes had to work twice for infrastructure and superstructure. As a result, they installed 3 boilers and heat pump with BEO fields at the underground, which will distribute heat energy to the entire building and send it to the 1,700 square meters underfloor heating, or 264 radiators. Cooling were activated by chilled beam systems and one integrated big cooling machine, which uses twice electricity than boiler unit. For ventilation, air handling units controls the amount of incoming and outgoing air and prevents heat and moisture loss by retrieving them. Air groups were divided into 2 categories, which are high height and low height. Devices for a high rise were installed at the rooftop with the weather resistance reinforcement, and devices for a low height were for infrastructure. And 16 air groups were installed in entire structure, and they control the space's air quality by exchanging indoor air through duct system.
Porthouse has a daylight sensor. When mounted outdoors or in an area with plenty of natural light, This sensor analyzes the ambient light color temperature and directs the indoor lighting to match the detected color. This innovative sensor can drive indoor lighting to match the color and intensity of the sunlight throughout the day or create artistic lighting scene that will make midnight feel like a sunny afternoon. With continuous control, the overhead light dim continuously and linearly from maximum electric power, maximum light output to minimum electric power, minimum light output as the daylight illuminance increase. Another light sensor is the presence sensor. With reliable detection of presence and motion, it forms the basis for the automation of important functions such as lighting, burglar alarm, music, heating, ventilation or cooling, and much more. With these two light sensors, allow the porthouse to maximize energy efficiency.